So in this video, let us look at some useful terms in conic sections. So we have already seen that the fixed point that we have for conic is called the focus, and the fixed line is called the directrix. It's called the directrix, and the fixed ratio that we use is called the eccentricity. So these are three terms that we have already learned. Now there are six more terms, which are axis, vertex, center, latus rectum, focal chord, double ordinate. So let us see what these are. First, axis. Axis of a conic section is the perpendicular drawn from the focus to the directrix. So once you have a focus and the directrix, so if you draw a line which is passing through focus and perpendicular to the directrix, you have something called the axis of the conic section. So through focus perpendicular to directrix is called the axis of the conic section. Next, what is the vertex of the conic section? So once you draw the conic, you get some curve. Depending on the eccentricity, you get different types of curves. But once you get the curve, the point where the curve cuts the axis, is called the vertex of the conic section. So curve cuts axis. Axis is that we have learnt before. So wherever the curve cuts the axis is called the vertex. Next, what is the center of the conic? The center of the conic is a point which bisects all the chords passing through that point. A point, if it is present, it need not be always present, a point which bisects all chords passing through it, is called a center. For example, if you have a circle, we have seen that circle is also a conic section. So if you take the center of the circle, so you can see that every chord passing through this point is being bisected by this point. So if such point exists, that is called the center of the conic. So if you take an ellipse also, you have some point which is symmetrically present in the center, such that every chord passing through this point is bisected at that point. So that is called the center, the point which bisects all the chords passing through it. So some conics might have a center, some conics might not have a center. Let us look at it with respect to individual curves. Latus rectum. Latus rectum is the chord through focus perpendicular to axis. So if I draw a chord through the focus which is perpendicular to the axis, if I call it PQ, so this is called the latus rectum of conic. A chord through the focus perpendicular to the axis is called the latus rectum, and PQ length is called length of latus rectum. Next, focal chord. Any chord passing through the focus is called a focal chord. Latus rectum is also a focal chord. So any chord through focus, any chord through the focus is called a focal chord of the conic section. And double ordinate. What is a double ordinate? A double ordinate is a chord perpendicular to axis. So any chord perpendicular to axis is called a double ordinate. So latus rectum is also a double ordinate. So apart from this, if you draw any line, any chord which is perpendicular to the axis, all these are double ordinates. So all these are double ordinates. So a double ordinate which is a focal chord is a latus rectum. A focal chord which is also a double ordinate is called the latus rectum. So latus rectum is the intersection of this and this. So we have double ordinates, we have focal chords. So what is a chord which is a focal chord as well as a double ordinate? That will be the latus rectum. So I hope you understand all the terms. Now let us try to move forward. The center of the conic, if present, can be calculated very easily. So if you have a conic section ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So we can assume this as phi of x comma y is equal to 0. Some expression of x comma y is equal to 0. So we have understood that this equation represents a conic section. Now suppose that this equation has a center. So how do we find the center? Center can be found by solving dou phi by dou x is equal to 0 and dou phi by dou y is equal to 0. So if you solve these two equations, if there is a center, so you get the coordinates of the center. For example, so if you take the equation x square minus 6xy plus y square plus 6x minus 8y plus 1 is equal to 0. So if you have this curve, let us first see what this curve is. So let us try to categorize this curve. To categorize this curve, let us first find delta. 1 minus 3, 3, minus 3, 1 minus 4, 3 minus 4, 1 is equal to 1 times 1 minus 16 is minus 15 plus 3 times minus 3 plus 12. Minus 3 plus 12 is 9 plus 3 times 12 minus 3 is 9. So 27 plus 27. 54 minus 15. 54 minus 15 is 39, which is not equal to 0. And the second step is h square minus ab is equal to 9 minus 1 into 1 is equal to 8, which is positive. So delta not equal to 0 and h square minus ab is positive. Hence, the curve is a hyperbola. So how hyperbola looks, we'll look in the chapter of hyperbola. For now, just agree that this is a hyperbola. Now what is the center of this hyperbola? So if you want the center, so that can be found out by solving dou phi by dou x is equal to 0 and dou phi by dou y is equal to 0. So what is dou phi by dou x? 2x minus 6y plus 6 is equal to 0 and dou phi by dou y minus 6x plus 2y minus 8 is equal to 0. So you need to solve these two equations. So what I do is I'll multiply the first equation with 3, and if you add them, 6x minus 6x get cancelled. So minus 18y plus 2y minus 16y, 18 minus 8 plus 10 is equal to 0. So y is equal to 5 by 8. And if y is equal to 5 by 8, you can find the value of x. So x is equal to 3y minus 3. That is 15 by 8 minus 3. 15 minus 24. So 15 minus 24 is minus 9 by 8. So hence the center of this hyperbola is minus 9 by 8 comma 5 by 8. So as simple as that. So solve dou phi by dou x is equal to 0 and dou phi by dou y is equal to 0. You get the center of the particular conic section if it is present. Thank you.